9-6, the distance and midpoint formulas. We are actually going to take this section and divide it into two for this year. So we will do 9-6A and 9-6B. 9-6A will be about the distance formula, and then the next day we will do 9-6B, which will be the midpoint formula. So today we're going to talk about the distance formula. The distance formula is related to the Pythagorean theorem, which you talked about yesterday. And as you can see, we're going to be finding the length of this line. And we can do that. You can see how it's sort of related to the Pythagorean theorem, right? We can look at how long this is and how long this is and use our a squared plus b squared formula and figure something out. I'm not worried that you know how we get a distance formula from the Pythagorean theorem. I just want you today to know that that's what it's based on. All right, we can look at the length of MP, and we can see that it's 1, 2, 3, 4, 5, 6, 7 units long, right? And we can look at the length of PN and see that it's 1, oops. My bad. 1, 2, 3 units long. And we could figure out, if we called this C, we could figure out C squared, something like what you learned last night, times, and figure out that C squared is 49 plus 9, or 58 is C squared, right? And C would be the square root of 58. That's what you were doing in lesson 9-5, Pythagorean theorem. We can know the value of the points and come up with a very closely related formula that we're calling, that is known as the distance formula. This is what I want you to worry about. I just want you to know that it's related, okay? That's all I really want you to know. The distance formula is the length of this line segment, right? You'll remember a line segment is the definition of a line segment is 2 endpoints and everything in between. Okay? But we're going to find the length of that line segment. The way we do that is we find the distance of, and here we're going to find the distance of MN. And that will be, so we have 2 points. We have this point and we have this point, right? So we have x sub 1, y sub 1, just like we labeled before, x sub 2, y sub 2. Same kind of labeling as we've used before on slope. So we're going to do, this formula is x2 minus x1. So x2, it would be negative 4 minus x1, which is 3, squared, plus y2, which is 3, minus y1, which is 0, and that is squared. So the distance of MN is the square root of negative 4 minus 3 is what? Or negative 4 plus a negative 3 is negative 7 squared, plus 3 minus 0 is 3 squared. So the distance of MN is the square root of negative 7 times negative 7 is 49, plus 3 times 3 is 9. So the distance of MN, as you can see, is the square root of 58. See how that's related to what we just talked about? Okay? This is the formula that we'll be using in this section, the distance formula. Please take a minute, very carefully write that down in your notes. I'm going to strongly recommend every time you do a problem, since you are just learning this formula, that you write down the formula first. Then your next step will be to write the numbers into where the formula is. All right, let's try another problem. Let me see if I can get my screen up here. I don't think I can. All right. We are going to find the distance of GH. All right? We have 2 points. We have point G and we have point H. So first thing I'm going to do is I'm going to label my points. G, here we go, x sub 1, y sub 1, x sub 2, y sub 2. Doesn't matter which point you label as first and second, as long as you're consistent, okay? The distance from here to here is the same as the distance from here to here, right, guys? So it doesn't matter which one comes first. Okay, so now we'll use our distance formula. The first step is to write down your formula. Oops, sorry. Goodbye. All right? And then you plug in your numbers, okay? GH, the distance of GH, right, will be the square root of 2, x sub 2, minus x sub 1, which is negative 3, and that's going to be squared. And then plus negative 4 minus 1 squared. And you figure out what is 2 minus a minus 3. That means plus plus. So that'll be the square root of 5 squared plus the negative 4 plus a negative 1 is a negative 5 squared. So the distance for GH will be the square root of 25 plus 25, or the square root of 50, which, if you pull out your calculator, you will see that it is approximately 7.1. It did say round to the nearest tenth. Okay, so the distance from G, between G and H, is about 7.1 units. You might want to stop this, rewind, play this section again. I highly recommend that you very slowly take the notes and go step by step through this process, one time all the way through in your notes. Please do not just write down definitions. Make example problems for yourself to look at, all right? Pause it, get what you need, replay it if you need to, and then move on to the next page. The distance formula can also be used to solve geometry problems. So here we have a geometry problem. It says, find the perimeter of ABC to the nearest tenth. Find the perimeter. So you'll remember the perimeter means the length around an object. So we need to find the length from starting at A, going to B, down to C, and up to D. That means we have to find the length of AB, the distance of AB. Oh, wait, let me rewrite that, guys. Excuse me. We're going to have to find the distance of AB. We're going to have to find the distance of BC. And we're going to have to find the distance of AC. So we'll be doing, yes, that's right, 3 distance formulas. How exciting. No moaning and groaning allowed. You won't have a ton of these problems, I promise. But I do want you to see the idea that you can use the distance formula 3 times to find a perimeter. Okay, let's try this problem. All right, here we go. So we have, oops, come back, highlighter. So we're going to find these, the perimeter, right? Let's start with side AB, right here, okay? We're going to find this distance first. And here they've written, you have your points, -2, 3, and 2, 2, all right? So let's label our points x1, y1, x2, y2. Here's our formula. Next step, we've written that down. Next, we're going to plug in the numbers. 2 minus a minus 2 squared plus 2 minus 3 squared, right? So we've gone x sub 2. Let me erase that. That may be hard to see. I won't write over the letters. I'll let you just see. So I'm taking x sub 2, which is 2, and writing x sub 2 here. And x sub 1, which is negative 2, so I'm going minus a minus 2. That'll change to a plus plus, I know. I'm going to go ahead and do that. I'm going to square that. And then I take y sub 2, which is 2, and put it here, and y sub 1, which is 3, and subtract it. 2 minus 3. All right. Square root of 2 plus 2 is 4, so 4 squared plus negative 2 minus 3 is negative 1 squared. 4 times 4 is 16, so we have the square root of 16 plus negative 1 times negative 1 is 1 squared is 1. So the distance of AB is the square root of 17. We'll do the same thing for side BC. Here are our points. We have the point 2, 2 and the point 0, negative 3, and we're going to find the distance between those two. Again, label your points x1, y1, x2, y2. Write down your formula. Okay, write it down. Yes, write it down. And then plug in your points. x2 is 0. x1 is minus a 2. y2 is negative 3. y1 is 2. 0 minus 2 is negative 2 squared, right? Plus negative 3 plus a negative 2 is negative 5 squared. Negative 2 squared is a positive 4. Negative 5 squared is a positive 25. You add those two together and you get the square root of 29. And that is the distance or the length of BC. And then finally, we have the length of CA. Again, you're going to plug in the numbers. x1, y1, x2, y2. Write your formula, plug in your numbers, calculate. Right, here we go. We have negative 2 minus 0 squared plus 3 minus a minus 3 squared. Negative 2 squared is 4. Negative 3 minus minus plus plus is 6. 6 times 6 is 36. Add them together, and the distance of CA is 40. Okay? So we have all three of our distances that we needed. So the perimeter would be square root of 17 plus the square root of 29 plus the square root of 40. Did they ask us to round to the nearest tenth? If they did, of course, then you'd calculate each of these to a decimal and add them. Not too painful, just long. Long is okay. That's like just doing 3 problems. So for every one of these, you will have, if you have 3 problems to do within a problem, we're going to give you less to do, not to panic. All right, here are your practice problems. Number 1, oops, I'd like you to explain the distance formula in your own words. Yes, we will read these aloud in class. I want to hear how you guys say this in your own words. Then I'd like you to find the distance between each pair of points, problem number 4 and problem number 5. Good luck with it. Maybe worth listening to a second time after you've taken your notes and just hear it all through it and process it. Good luck with it. I think that's really it. Yep, that's it. Thanks, guys.